My research topic is a study for design and development of model by automated machine learning and deep learning techniques for classifying diabetes mellitus. Now, the content of this presentation and this research, first one is introduction, review of literature, research methodology, result analysis and interpretation, conclusion and suggestion, and now last one is reference. So first I will introduce the my research. In my research, main focus is on diabetes classification. Diabetes mellitus is global health issue and accurate diagnosis is essential for timely treatment and better patient care. This research and this project mainly focuses on developing an advanced model using automated machine learning, AutoML, and deep learning to improve the classification and prediction of diabetes. By leveraging AI, the model aim to enhance diagnostic accuracy and support healthcare professional in making informed decision. Now, a diabetes mellitus is long-term disease where blood sugar level becomes too high. To manage and treat it properly, we need accurate, efficient tools for diagnosis. Traditional method use manual analysis and statistical techniques, which take a lot of time and can sometimes inaccurate. So recently, automated the machine learning and deep learning have changed medical diagnosis, making diabetes detection faster and more accurate. This study focuses on improving diabetes classification and diagnosis using this advanced AI technique. Now, the key concept is AutoML, automated the process of building machine learning model. Deep learning is that mimics the human brain to find complex pattern in medical data. I will discuss in thoroughly in next slide what is AutoML, deep learning, AI healthcare, what is the that helps in faster, more accurate diabetes diagnosis. Now, the statement of the aim, the study seeks to harness the power of this advanced methodology to build an accurate, scalable, and efficient model that can facilitate early detection and diagnosis of diabetes. By integrating automation in the machine learning process, the study aims to streamline the model development, reduce human intervention, and enhance the model's predictive performance, thereby contributing to improve patient care and management. Now, the aim of the actual statement is a study for design and development of model by automated machine learning and deep learning techniques for classifying diabetes mellitus. Now, why need this study and scope of the study? Need of the study: diabetes is a leading cause of severe health complications worldwide. Early and accurate diagnosis can help prevent serious conditions like heart disease, kidney failure, and vision losses. Traditional method requires significant expertise and time also, while AI-driven models can offer fast and precise diagnosis. Then the scope of this study: the model will be trained on medical data sets to identify diabetes risk factors. It will integrate AutoML to make the model accessible even to non-expert, and also the project has potential application in hospitals, clinics, and healthcare research. Now, the following are the main objective of the study. Now, the first is discuss about AutoML and deep learning techniques applied to medical diagnosis with a focus of diabetes mellitus, and to identify and gather diverse data set containing clinical, genetic, and lifestyle data relevant to diabetes mellitus, to design and implement automated machine learning pipelines to explore and compare various type of algorithm like decision tree, enable ensemble methods for diabetes classification, to design deep learning model to diagnosis of diabetic retinopathy. This is the eye effect by when sugar level is increased in sugar level is increased in blood, then that will cause to your eyes and your vision. So this is the diabetic retinopathy. To propose recommendation for effective implementation of AI driven diagnosis tools in healthcare setting. Now, the machine learning. What is the machine learning? Now, machine learning is a part of artificial intelligence that helps computers to learn from data and improve their performance without being directly programmed. Now, this machine learning is a subset of artificial intelligence that involves the development of algorithm and statistical model that computer system use to perform a specific task without explicit instruction. Instead of this system learn and improve from expertise or learn from experience data automatically. Now, the how it will work, machine learning will work. Data input, first we will give the data input, the system receives the data, maybe images, text or numbers. Pattern recognize, identify pattern and trend in the data. Learning process, the system learn from past example and make prediction. Improvement, with more data the system gets better at making decision. Now, I will extract the text from the second uploaded image, means that we can take the example, we can give the text or we can give the image, then we at the last, after the trained model, we can extract the image and new data from the machine learning model. Now, next is the deep learning. Deep learning is a specialized subset of machine learning. This deep learning techniques is enhance the machine learning models accuracy. Machine learning models goes in advance when we use the subset of the machine learning, deep learning. Deep learning has proven high effective in tasks such as image and speech recognition, natural language processing, and medical diagnosis. Now, the deep learning is an advanced type of machine learning, we can say, that uses artificial neural network which mimic the structure and function of human brain. The image also said that artificial intelligence, machine learning, and deep learning. When we apply the machine learning, this will be the subset of artificial, and when we apply the deep learning in machine learning, then this subset of the machine learning, deep learning is the subset of the machine learning. Now, main focus is on automated machine learning. We are using in this study automated machine learning. Traditional machine learning workflow and automated machine learning workflow are shown in the image. When traditional machine learning, AutoML, refer to the automation of process of applying machine learning techniques to real world problem, including model selection, hyperparameter tuning, and feature engineering. Now, the key feature of AutoML basically technology that automated the step involved in applying machine learning. First, the key feature of the automated machine learning, model selection. Now, in the machine learning, we select the data, we input the data. In automated machine learning, we select the model, which model is best to classifying diabetes mellitus. Now, the in the automated machine learning, we choose the model, not the data. We choose the best model to classifying the any of the things. Now, the hyperparameter tuning adjusts model setting to improve accuracy. We will work on different type of model, then we choose the best model in automated machine learning. Feature engineering, select the transform the best data training. Now, I will give the small introduction of the diabetes. Now, the diabetes is metabolic diabetes mellitus is a long-term health condition where the body has high blood sugar level due to either insufficient insulin production or the body inability to use insulin properly. Is called insulin resistant metabolic disorder characterized by high blood sugar level over a prolonged period, resulting from inadequate insulin production or cells ineffective response to insulin. Now, the type of diabetes, first is that mellitus type 1. Type 1 diabetes. We can say in a simply, the type 1 diabetes, the body does not produce insulin. In this type 1 diabetes, we can can say insulin dependent diabetes mellitus. Our immature onset diabetes is responsible for between 5 and 10% of all cases of diabetes mellitus and type of diabetes that have been diagnosed. Without we have to give the patient, we have to patient have to insulin properly, and we have to externally input as a insulin for diagnosis. Autoimmune, genetic and environmental factor are the primary contributor to the decreased prevalence of risk factors for type 1 diabetes. In a young people, the development of type 1 diabetes is more likely to occur. Now, the diabetes type 2, simply we can say the body does not use insulin properly, or we can say insulin resistant. In this form, diabetes that develop in adult and can affect people of any age, including children. However, it is most commonly found in person who are middle age or older. There is a correlation between type 2 diabetes and people who are overweight, inactive, because of a condition known as insulin resistance, which happen when fat, muscle, and liver cells do not have enough insulin to transport glucose into the cell of the body as a source of energy. It is primary cause of this order, because the work of the insulin is to transport glucose into the cells of the body as a source of energy. In order to facilitate the transport of glucose in the cells of body, the pancreas must produce a greater quantity of insulin. That is requirement. In the event the level of sugar in the blood rise, the pancreas will not make enough insulin, and the patient will require treatment for type 2 diabetes. Now, the type 3 diabetes. Now, the type 3 diabetes is not an official recognized type, but is used to describe the link between insulin resistance in the brain and Alzheimer disease. It suggests that the poor insulin function in the brain can lead to memory loss and cognitive decline, similar to dementia. We can say dementia. Some research journal and some medical advisor or some books give the classification. The third type of diabetes is the name. This is not the given the type number, but this is the gestational diabetes is associated with type 4. We can say some papers can say this is the type diabetes of type 4, but some good journal and good book author said that this is not the we can't categorize in a type. This is the name only. Gestational diabetes is associated with 4 type diabetes. Onset or initial detection of gestational diabetes occur during pregnancy. Gestational diabetes is characterized by a lack of carbohydrate, which lead to hyperglycemia of varying severity. In addition, it does not rule out the potential that the glucose intolerance may have existed before to pregnancy, but had not been noticed up until this point. It is irrelevant whether insulin is used for treatment or whether the condition continues after pregnancy. The definition is applicable regardless of either of these factors. Now, review of literature. I have reviewed the most commonly used the technique, and most published review paper Reduce et al. 2024 highlight the challenges of automated machine learning. Now, the main challenges of in this research journal, uh, this is the intelligent discovery assistant. Now, how we can say ADI, intelligent discovery assistant. Main issue in this research: high computational cost. AutoML require a lot of computing power, making it expensive. Limited task support. Some tasks cannot be fully automated. Fixed evolution matrices. AutoML relies on preset performance measures, which may not always be suitable. Now, the proposed solution on that particular research paper, uh, by my study, a human in the loop approach, where past machine learning pipelines are used to recommend optimized solution based on user query. Now, second research paper published in 2022, Click et al. Propose on online automated machine learning system to handle data drift in dynamic environment. Their approach optimized online learning pipeline using asynchronous genetic programming and successive halving experiments show that uh, automated or we can say online automated machine learning adapts better to changing data distribution compared to existing online learning model. In this, we have give the proposed solution. Now we have captured the problem in real world application. Data keeps changing over a time, called data drift. Traditional AutoML system struggle to adjust quickly. Now, the proposed solution, online automated machine learning system that continuously update models in dynamic environment, use asynchronous genetic programming inspired by evolution and successive halving, a technique to speed up model selection. Now, the third one is Posoldova discussed the growing interest in machine learning and artificial intelligence. This is the 2020 paper. The overview of this research paper: machine learning and artificial intelligence are powerful tools for prediction outcome based on data. Common application include text prediction, sentiment analysis, and recommendation system. Now, the misconception of this paper is many people think. Uh, Machine learning is a black box that magically finds solution. Not at all. But in reality, it works by identifying pattern in a data and applying learned rule. This is the totally based on the past experience. We can collect data, we can experience the data, then we can process the data, then one model is prepared. Now train the model. Different type of model we have prepared in the my research, and we are used automated machine learning. Then automated machine learning will select the best model to predict the diabetes mellitus. Now, many of the paper I have included and I have studied in this research. John D. Automated Machine Learning 2020. This paper explored the application of AutoML in healthcare, focusing on disease prediction and patient management. Now 2021, the study discusses the implementation of deep learning algorithm to predict diabetes with high accuracy. And third paper is 2022 AI technique for medical diagnosis. I have studied this paper very thoroughly. A review of various AI-based techniques used in the diagnosis of multiple disease, highlighting their effectiveness. Now, 2023 paper, Robert Brown machine learning model for disease classification. I have also included in the list best and my studied paper. Three paper I have discussed in previous slide. So these three papers are also included in this. Now 2024 neural network in medical imaging. Neural network is the deep learning technique. Now they explore the use of neural network in medical imaging for early disease detection and treatment planning. Now Castellon, Neves, uh, Dagoberto, and Garcia 2023 paper published automated machine learning simplify the design and optimize of ML model. Now, but raises concern about resource consumption and environmental impact. The study focus on sustainability in AutoML using the skit-learn package and evaluating energy efficiency in a Bayesian and random search algorithm. Now, three paper I have also included in the my research. 2000 all three papers are published in 2024. Deep learning for early detection of diabetes mellitus. Now human in the loop strategy for data science pipeline, and third one is 2024 automated machine learning. Now the first paper, the research focus on using deep learning for early diabetes detection, highlight the significance of processing to handle missing value. Now The second one is study address the challenges of automated machine learning, introducing a human in the loop framework for designing data science pipeline instead of relying on a similarity of that project. Cruz Harned, Yaren, 2024. The paper present an automated machine learning approach combined with multi-objective optimization algorithm to enhance manufacturing productivity. The method embedded AI model into genetic algorithm for parameter optimization. Experiment result is that the 2.15% from a small manufacturing firm indicate 3.19 increase in productivity and a 2.15% reduction in defect making. This an efficient alternative to traditional trial and error method. Now, all the paper is studied, and I have find the research gap. What is the what will be the research gap in the all the study and all the published paper? Now, the lack of comparison between traditional ML and automated machine learning in healthcare. Focus on binary classification, difficulty in understanding model prediction, black box problem. I also discussed this black box problem, limitation in available data, and most data sets are small and lack diversity, meaning they may not represent different age group, uh, ethnicities, or health conditions. This make it hard for model to work well in real world medical setting. So we have included the research gap. There is a lack of comparative study between traditional ML and model automated healthcare. Now, the most research focus on binary classification rather than distinguish that diabetes type, posing 1 and 2, gestational, posing data and feature selection changes, model interpretability remain a concern limiting clinical adoption due to the black box nature. Now, additionally, existing data sets also lack size, diversity, and real world application affecting model generalization. Addressing this gap is crucial for developing accurate, reliable, and interpretable model for diabetes detection and management. Now, the research methodology. Now, proposed research methodology. This study follows an applied research design, meaning it focuses on solving real world problem rather than just expanding theoretical knowledge. Instead of only studying concept, applied research aim to find practical solution that can help doctor and medical practitioner improve diabetes treatment. In this case, the research will examine different diabetes treatment strategy based on insight from experienced physician. The goal is to provide recommendation that can enhance diabetes management and treatment approach. Now, the applied research aim to address specific issue or challenges faced by practitioner in particular field as a approach to basic research which seeks to expand theoretical knowledge. Now, simple technique. The study uses a non-probability quota sampling method. This means that instead of randomly selection participants, the research choose them based on a specific criteria. We are we can't use random selection because this is the very crucial and very important to diagnosis of classification, means that which type of sugar, which type of diabetes mellitus. Now, for this study, physician and medical practitioner with 5 to 10 years or more experience in diabetes management will be selected. This assure that the study capture a diverse range of expert opinion on diabetes treatment. Now, the proposed approach is the study collects secondary data from reference, the internet, and medical research publications. After analyzing the data and getting expert recommendation, a specific rule are created for the machine learning model. These rules are stored in CSV file, which serves as the dataset for the ML model. The ML model runs on Google Colab, a cloud-based Google Colab. I will discuss this in briefly. A cloud-based platform that allows efficient execution of machine learning algorithm. The data set consists of numerical data on diabetic symptoms, helping the system predict different type of diabetes. Now, the image classification using Fast AI library. The study uses Fast AI, a powerful AI library that helps programmer build ML model with fewer lines of code. Fast AI is built on PyTorch, a widely used deep learning framework. This research focuses on image classification, specifically training a computer to detect diabetic retinopathy, diabetes related eye disease. This is called the diabetes related eye disease using the Kegel diabetic retinopathy detection dataset. Google Collaborati collaboratory. Now, this is the online coding platform. Simply, you can write and run Python code in your web browser. No setup is needed. No need to install Python or any libraries. Everything runs on Google's cloud, free GPU and TPU. Google provides free access to GPU for AI ML tasks. Easy collaboration, just like Google Docs. You can share notebook with other and work together in real time. Access to Google Drive, you can easily save and load files from Google Drive. How to use Google Colab? Go to Google Colab, click new notebook to create a new project, write Python code in the provided cell and press shift plus enter to run. Install additional library if needed using pipe install library name. This is the syntax to install additional library. Save your work directly to Google Drive. Now, the proposed tool and model CAN using fast AI. CAN convolution neural network is a type of deep learning model used mainly for image classification, object detection, and image recognition. Fast AI is a Python library. What is the fast AI? Fast AI is a Python library that makes it easy to build and train deep learning model, especially CNN with minimal code. Convolution neural network. How CAN work? Um, take an image as an input, extract important features using convolution layers. Now recognize pattern like age, shape, or texture. Classify the image based on learn feature. Now the CAN using fast AI. Why use fast AI? Why we need to use? Easy to use, pre-trained model. Now use model like res net matlab reset and now resnet to give better accuracy. Automatic optimization handles learning rate and training efficiently. Work with PyTorch. Easy to work with PyTorch. Build on top of PyTorch for deep learning key steps in code. Download dataset. Use FastAI built-in dataset loader. Prepare data, load image and create label automatically. Train CAN model uses ResNet 34, a powerful pre-trained model. Now, then make prediction. Test the model on new image. This image is also shown here. Testing of model. Now, developing an machine learning model for diabetes detection is primarily focus of this research. A major challenge for rule execution and implementation is acquire the correct user or diabetic symptom. A person's status as a diabetic patient as well as the kind of diabetes 1, 2 are gestational is determined by this combination of information. We put our machine learning model through its paces with 180 patients. When it comes to physician, it has gotten the job done. In order to swiftly and successfully detect different form of diabetes, researchers have developed a machine learning model in developing nations where medical professionals are in short supply. This aids patient less reliance on medical professional is the goal of this smart machine learning model. Decision may be made more quickly and accurately by both physician and patient with its support. Now, understanding of diabetes and its prediction using AI. Diabetes mellitus, commonly known as diabetes, is a widespread health issue. Now, this is the essential to develop a system that can accurately detect diabetes and its different types are early as possible. In this study, we introduce a machine learning model to improve the accuracy and efficiency of diabetes prediction. In this study, we have also developed an study of developing the automated machine learning, which can select the model, the machine learning model. One of the serious complications of diabetes is diabetic retinopathy, a condition that affects the eyes and can lead to vision problem. To detect this condition, we use convolution neural network (CAN), a type of deep learning model. The CAN model was tested using a dataset containing eye image with and without diabetic retinopathy. The model accuracy was measured to check how well it can be predict the disease. This research shows that AI-based model can help in early diagnosis and better management of diabetes, making healthcare more efficiently. Now, the result analysis show that this is the analysis and interpretation. We have prepared the table. Family history, age, obesity, and the number is the diabetes 1. If patient have a diabetes 1, we will enter the 1. If have not have a type 1, then 0. True and false, yes or no. We are in the family history, we will put if yes, then put the 1, and if no, put the 0. Now age 11, 12, and 12. Now this is the age criteria. We have selected the number. I will explain in the next slide. Obesity, previous IFT, IGT, all the parameter, all the 64 to parameters we have included to capture the data from the different 150 patients. Now, family history, Boolean value of the symptoms. Family history, if true, 1, enter 1. If false, enter 0. Now the second is obesity. If obesity is low, 21, normal 22, and obese high means 23. Now age, young. If patient is young, we will enter 11. If patient is adult, now we will enter 12. If patient is old age, now we will enter 13. Now third is uh, tri triglyceride. Triglyceride, normally normal. If normal, we will enter 2, and borderline, now we will enter 3, and high, now we will enter 4. And hypertension, normal 3, elevation 4, high 5, and very high 6. HDL cholesterol level, very high, we will enter 5, low 1, medium 2, and high 3. This is the Boolean value symptoms, multi-value symptoms. So we have use the multi-value and Boolean value symptom. Machine learning model, the most effective and methodological approach to multi-class classification is to use a decision tree classifier. The job description uses the dataset to query. Decision tree categorized may be best presented by a binary tree. Each level of the decision tree involve pausing, inquiry, and subsequent node separation based on information with the distinct attributes. The depart node is referencing the class to which it belongs whenever dataset is divided or split. To train the decision tree classifier from skit learned researcher use the following code. We employ the class decision tree classifier, which has greater capacity. It and performance ability for the multi-class classification of the dataset. Now the proposed dataset, here is a dataset containing values that make up the expert system knowledge base and rule. A machine learning based expert system is knowledge base consists of the following rules inserted into the dataset. Now the CSV file we will upload it for the model. Now this is the library dataset input. Researchers use functional library to execute computer code correctly. The following code assist with the important library. This is shown in the image. Now the library dataset import. First is dataset import and preparation. Load the dataset and store label in variable. Now use df.head to view the first few rows and diff.shape to check row column count. Now data splitting, train and test. Train and test. Sort data into training and testing sets based on label and attributes. Use train underscore test underscore split from skit learn to divide the dataset normally. Model Training and prediction. Train the model using the decision tree classifier. Use the predict function to test and genetic output. Overfitting issue and solution. Overfitting can occur while creating the knowledge. Best to fix this, apply the right optimization method and test different type of solution. Now the result and discussion. The machine learning model was tested on 150 diabetic patient for validation. Out of 180 test cases, the model achieved a 94 accuracy. It predict diabetes type using D-tree model, predict based on patient symptoms. The algorithm analyzed symptoms from the dataset to provide a recommendation. 5 test cases were verified using data from 5 selected patients. The model helps identify diabetes type based on input symptoms. A literature review compared this system with existing diagnostic model and expert system. Now, the predictive study play a crucial role in medicine, pharmacology, sociology, and healthcare. Machine learning has significant potential in diagnosis diabetes complications like retinopathy and neuropathy. Continue research aim to enhance prediction accuracy by identifying more precise symptoms and using advanced technique. In this study, an ML model for diabetes prediction was tested on 150 individuals using 5 real cases. The model achieved a 94 accuracy comparable to human doctor. Future improvement in data collection and AI advancement can further enhance prediction accuracy and early diagnosis. Now, the reasoning with certainty factor. What is the certainty factor? Dealing with the uncertainty is a common challenge, real life and decision making. In healthcare and AI, we use a concept called the certainty factor. What is the certainty factor? Certainty factor tell us the probability or confidence level that sometime true. It help in making more accurate prediction in uncertainty situation. Why is CF important in healthcare? Medical conditions are often complex and uncertain. Certainty factor help in analyzing symptoms are more accurately for better diagnosis. How does CF work in diabetes prediction? When creating a dataset for machine learning model, the patient's belief level about their symptom is included as a CF certainty factor. This helps in fine tuning prediction by considering how certain a patient is about their symptom. How is CF applied in AI and machine learning? AI models use CF based reasoning to weight evidence before making a decision. It improves accuracy and reliability in disease diagnosis. Benefit of using certainty factor in healthcare: reduce misdiagnosis by considering uncertain symptoms, enhance AI decision making by adding human-like reasoning, improve prediction model for disease like diabetes, heart disease. Now, certainty factors, we have represented a column A, type 2 diabetes, B type 1 diabetes, we are represent A as a type 2 diabetes, B as a type 1 diabetes. Certainty factor A is for diabetes type 2 and certainty factor B is type 1 diabetes. Now, this table is about the symptoms with the CF value entered by patient with prediction type of uh, diabetes notified by tech. Increased thirst, increased urinate, increased appetite. Now, this is the A is the 1 1 and B is also 1 1. Then A is right because CF factor A, diabetes 1, 2 is the 0.95, 0.95, 0.90, and 1 is 0.30, 3.30, and 0.10. So we have predicted type 2 diabetes. So the model predict that patient is suffering from type 2 diabetes based on symptom number 8, CF 8.98, and symptom number 9, CF 9 equal to 0.9. Therefore, a high CF value is required for type 2 diabetes. Now, this is the decision tree for binary 0 1 value of symptoms. This is the decision tree prediction of diabetes type 1. If 0 it is false, and if 1 it is yes. Now this is the decision tree and return to parent node if not. type 1 diabetes diagnosed, type 2 diabetes, and gestational diabetes. If yes, then decision tree will give the based on the data taken from the CF factor and table. Now this is the including CF factor. This tree is without CF factor, and this tree is accurately using the CF factor. Now prediction of diabetes type 1: symptoms as a CF value, symptoms as a CF value, symptoms as a CF value. All these tree will work on based on certainty factor: type 1 diabetes, type 2 diabetes, and gestational diabetes. A measure of their conviction: the severity of their symptoms. Patients are asked to record their certainty factor. The decision tree method build the tree based on this confidence factor data, which is determined using the criteria of -1 to 1. CF factor varies from -1 to 1. These characteristics represent the knowledge gain instead of using binary 0 or 1. Symptoms value for classifying is figure shown 1 and 2. Figure 1 is shows without CF factor, and 2 is the with certainty factor. Figure 2, the decision tree uses certainty factor to improve the categorization. Research have developed a novel method that integrate AI expert with machine learning. Here we will classify diabetes kinds using a basic decision tree method, a non-parametric supervised learning technique in order to comprehend and construct the rule of the system. This model uses the symptoms stored in the dataset as a row as a rule. The model then use is then symptoms to forecast the class of diabetes. You may further improve the processing and prediction accuracy by including certainty factor approach into your machine learning platform. Turning expert system into machine learning platform is as easy as following this generalized strategy. More precise healthcare forecasts are possible with consistent and high quality research. Now this is the deep learning model for prediction of retinopathy. And further, AI/ML deep learning may identify disease-specific pattern and link novel structure to enhance novel scientific understanding. It is said that hyperglycemia is a primary symptom of diabetes. Preventing problem caused by elevated sugar level is a major concern. Both macrovascular and microvascular complications may arise from diabetes. Figure is illustrated the eye defect by the sugar level. Now we have retinopathy, downloading image. The proposed work is downloading image data, then load and view data. Now create and train a model. We have created the trained model on basis of the this data, and this work to convolution neural network. This is the table showing the convolution neural networks. And now step 4, cleaning the data. Now when we clean the data, and the final interpretation and result is the class classification interpretation is used. Its function to interpret the result at the conclusion of the framework building. The learner framework provide accurate prediction by invoking the method by learner and sending it on. Now, accuracy of model: researcher define for these two classes issue as a number. Now, this is the non-diabetic 256, and this is the confusion metric. This is diabetes 72. Now, the non-diabetic 98, and this is the non-diabetic 72. This is the confusion matrix. Picture accurately recognize the diabetic retina, diabretina, we can say normal retina, and normal retina. Accuracy is defined by researchers as a percentage of test picture correctly. With 80% of accuracy, the final trained network was successful. If you want a higher level of accuracy, you will need a larger data set, and fast AICN can handle a large number of test photo will is quick prediction and response produced by this trained convolution. Now, the final result of the retinopathy, uh, researcher use of number of properly recognized picture as a diabetic retina, diaberetina, and normal retina. We have taken two pictures, determine a specific for these two class problem. Accuracy is defined by researcher in terms of retina picture that have been correctly classified. The final network design had an accuracy rate of 80%. Any number of images may be classified using the fast style library. Quick prediction and instant response are produced by the trained convolution neural network. Now, the sum of the test cases that the researcher has provided are as follows. Make a guess as the picture classification for we trained the model, virtual computer equipped with graphic processing, unit capable of more than 960 teraflop of execution per event are available via Google Cloud Service. Then V100, P4, P4, P100, Tesla, K80, NVIDIA, and T4 GPU bring DL modeling and simulation to life. Obtaining flawless GPU is possible for everyone, regardless of the scope of the extraordinary task in hand. Now, the use of deep learning technique in the medical field. Now, the use of this data deep learning technique in the medical field, which are based on image processing, illness detection, and risk assessment, is becoming more successful. The purpose of this research is study to propose a model for a diagnosis of diabetes retinopathy using fast AI. The model would make use of the fast AI library and would need less code in order to get better result. In turn of image processing model, this convolution neural network MO model is effective since it is trained utilizing a GPU system that is offered by Google Colab. A speedy and correct result may be obtained with the assistance of neural network that has been pre-compiled. This model that has been suggested is able to differentiate between photograph of diabetes retinopathy and photo of normal retina. The detection of all phases of diabetic retinopathy may be possible in the future with the development of modified model that utilizes a bigger data set as a mean of providing ophthalmologists with support in healthcare diagnosis. This CNN is available. Now, the conclusion of this study: research insights and impact demonstrated the effectiveness of AutoML and deep learning in a medical diagnostic showcase the transformative potential of this technique in diabetic classification, objective and model development aim to develop a robust and reliable model for diabetic classification, utilize AutoML for automated model selection, hyperparameter tuning, and feature engineering, integrated deep learning technique to capture complex data picture. Deep learning technique used employed convolution neural network and recurrent neural network enable feature extraction from high dimensional data for precise classification. Key finding is the conclusion: AutoML is streamlined model creation, making machine learning accessible to varied expertise level. Combination of AutoML and deep learning significantly improve classification accuracy, reduce human effort and time for manual tweaking and validation. Now, clinical significance: ensure quick and accurate diagnosis vital for clinical application, prompted early disease detection, personalized treatment, and better patient outcome, highlighted the potential of AI-driven diagnosis tool for informed medical decision, challenged and limitation: need for high quality, well-labeled dataset, high computational requirement for training deep learning models, model interpretability remain a challenges. Then the final conclusion of this study demonstrate the powerful combination of AutoML and deep learning in a diabetes diagnosis contributed to the growing field of AI in healthcare, paving the way for future advancement, emphasized the need for continued research and technical improvement. Now, the recommendation of study: enhance data quality and diversity, utilize high quality, diverse and well-labeled data set, collect data. This is main important for this study and result in utilize high quality, diverse and well-labeled data. Collect data from various demographic and location. Collaborate with healthcare organization for access to large representative data sets. Optimize model interpretability, improve clarity and usability of deep learning model for doctor, explore feature significance analysis, visualization tool, and model agnostic methods. Now, develop resource efficiency model, reduce computational requirement for broader adoption, use techniques like model pruning, quantization, and efficient network architecture. Now, the implement real world testing and validation. This is also the recommendation of the study. Conduct clinical trial and pilot study to evaluate real world performance. Gather feedback from healthcare professional on usability. Address ethical privacy concerns. Now ensure strict data confidentially and compliances with the privacy law. Mitigate AI biases to ensure fair and ethical decision making. Now, the suggestion of study, the enhance the effectiveness and real world applicability of the proposed AutoML and deep learning based diabetic classification model. The following key recommendations are suggested: advanced model architecture, domain specific integration, enhanced data pre-processing, real-time data processing, multimodal data integration, diverse population testing, and user-friendly interface. Now this is the bibliography references general. I studied in whole total study of this research. Now thank you. If any query or any questions, thank you very much.